So, for anybody that doesn't know him, Brian Deary is the chief scientist for the Factom Foundation. He's spent probably more time than any other human being on Earth working out the architecture and the protocol for Factom with Paul Snow. So, if you have technical questions about how the protocol works, how the incentive model works, how the system generally functions from a cryptographic standpoint, Brian is the man. So, Tim, if you like, we can kind of structure this just where I'll talk through a couple of slides. What's really interesting to me is Q&A and just kind of going back and forth. Don't want to put everybody to sleep just talking over slides. So, and then Brian can answer technical stuff, or we can dive into whatever you guys want.
Sounds good. Perfect.
All right, cool. So, do you have the slides up, or should I put them on my screen?
Why don't you share them on your screen, actually?
Okay, cool. Let me do that. Okay. All right, cool. Let me do that right now. Okay, cool. Let me know when it's coming through.
It's up.
All right, cool. So, for those that are sort of already familiar with Factom, you guys might already know that Factom is essentially a data layer for the blockchain. I really like the way that Paul describes Factom simply as a blank piece of paper that you can write any data structure, any information you want to, and it's basically designed to be immutable blank paper. So it uses the ledger of Bitcoin to keep things immutable and stored there forever in a way that can't be changed. And the basic architecture of how this is working is Factom is gathering all these documents or transactions or any data that people push into the Factom system, and all of those documents are aggregated every 10 minutes, and they're hashed into a block of entries. And the entry block is hashed into a single transaction into the Bitcoin layer. So if you can see from this diagram, it's basically like Factom is putting down anchors into the Bitcoin blockchain every 10 minutes. And that has some really cool effects, right? Now you can build huge applications for titles or medical records or financial applications, anything you could imagine. And you're not limited by the number of transactions you can put into Bitcoin. You can take millions of records, hash them together, aggregate them into Factom, and a single hash will get placed into the Bitcoin blockchain that secures all of those records. Because it's a hash, of course, the raw information, the document itself, is still private. All you're doing is basically timestamping that document because you can prove at any time in the future that that hash correlates to that document. So really, really, really simple protocol that Paul and the Factom team are building is really about publishing data into the blockchain in a way that doesn't bloat the blockchain, in a way that doesn't cost a dust level Bitcoin transaction for every document, instead of just using proof of existence where you put every single document into the blockchain. Now you can take thousands and thousands of records and put them into the blockchain for the cost of a single transaction. So it solves the cost issue. Imagine, you're Zynga or somebody like that, and you want to put 100 million transactions a day into Bitcoin to record game tokens or something like that. At that kind of level, dust level transactions add up into real money. And so if we're going to scale the blockchain, Factom offers a solution for that. So let me talk real briefly about a couple of use cases. So this is a really cool one. In the developing world, records and titles for land and home ownership are a really big problem. This is actually a real photo Peter, the president of Factom, took when he went down to the Central American country. And the government asked him, how can the blockchain solve this problem? We took all of our physical documents already, and we placed them into an Oracle database. But now bureaucrats and people are changing records, and it's the centralized database, and we don't have a way to audit what's going on, or if they're doing fraud, or if these government officials are corrupt. And so Factom offers an opportunity to take all those land titles that have been digitized and then hash them and record not only the existence of that document, but record the process itself, right? It's as much about solving the garbage in problem as it is about solving just making these records permanently immutable, right? So if you can imagine every step in this title process, now you can drop a hash into Factom and record exactly what it was at that point in time. And so if there is some corruption going on, you can cryptographically prove where the problem is and who altered the record or where the corrupt official is. So that's really powerful for these developing world governments and people that basically don't have access to secure titles, which leads to really high interest rates on mortgages and stuff like that in the developing world. Here's another big problem. KYC and AML compliance today is pretty much a nightmare, not only for users, but for the banks that have to hold all this information. We've seen everybody from Home Depot to Chase. They have these huge databases of user information, and it gets hacked. And so, Factom could allow you to, with revealed secrets, conduct AML or KYC and not have to store a local copy of that, but have the proof that KYC and AML has been done. And that would really, really improve security. So the Isle of Man has reached out to Factom about doing this they host a lot of companies that do gaming, poker and gambling and stuff like that. And they have to do all this AML and KYC, but it's a real pain. So that's potentially a good way to protect users' private information using this kind of approach. Lastly, just talk about general auditing, right? Today, all of the business processes, all of the money that moves around accounts is really tough to audit, right? Maybe once a quarter or once a year, people get an audit, and between those times, they can't really see what's going on in the system or if somebody's being corrupt or not following the right process. Take an example, something like Enron, where afterwards, everybody tried to alter records or remove emails or remove criminal activity. If you were capturing all that information in real time, you could basically have a real-time audit of all the business processes within a company. So that would give you like real-time accounting. So anyway, that's a couple of the use cases. Talk real briefly about the team. A lot of you might know Paul Snow. He's been programming for 30 plus years, doing rules engines and compilers and back-end systems, and has had a vision for a long time about building a decentralized system where you can build these processes. But before the blockchain, that was really impossible. So now that the blockchain exists, he's been pursuing Factom for about a year, building out the technology. Peter Kirby is the business guy, and the president runs around talking to all these different people that want to use the technology. A lot of you may know me from writing the Decentralized Applications white paper in 2013, and I run a venture fund. I just sit on the board of directors of Factom and try to introduce them to cool technology partners and developers. The team has actually grown pretty big. We've got 7 core developers now, 3 biz dev people, 19 financial and technical advisors, and 16 community evangelists all over the world. This is a picture of the team and some of the advisors and the Storage J guys from Miami a few weeks ago at the conference. So the financial model, just real quick, basically people pay to make entries into the Factom system. That's where the utility and the use of the tokens comes in. So those are paid out to the federated decentralized server pool that are aggregating all those transactions and publishing them to the network. All those servers are auditing each other in real time. So that's basically what they're doing in that 10 minutes before it gets put into Bitcoin. The basic model here is network usage and utility really drives demand for the factoids and all of the token use. So there is going to be a token sale later this year. We haven't announced a date, but we're looking at late first quarter, early second quarter type of time frame. Basically, imagine something very similar to Ethereum. There's not going to be a limit on the number of tokens. It's really going to be driven by the number of people that participate. The sale will only take BTC to make things simple and clean, but we'll offer channels, maybe refer people to Circle if they want to use a credit card or dollars so they can buy Bitcoin and then come back and participate, or refer people to Shapeshift if they want to take some other crypto coin and convert that into Bitcoin, then they can participate. The big thing that we're trying to emphasize is instead of just a plan and an idea, the goal is to have real working technology when Factom goes live at the end of the crowd sale. So what I mean is have an MVP where people already can play with the alpha version of the API. They can put data into Factom. They can audit it. The tokens are used in the system to sort of have all that up and running when we get to the end of the crowd sale and not have a gap between the end of the crowd sale and when the software is ready. So the team's already released the API, the consensus paper, the white paper, a lot of the protocol. So if you guys want to dig into that, there are links on the website for that. Also, the other cool thing is, since this is such a big pain for titles and finance and accounting, we're actually going to have a lot of real-world projects that we can show off even before the crowd sale and during the crowd sale for how people are using Factom. And it's a decentralized model. Anybody can get involved. Anybody can use the open source. Anybody can build projects on top of this. So definitely welcome everybody to do that. So, and then finally, the way the tokens are used is the factoids are converted to entry credits, and the entry credits are converted to entries in the Factom system. And that's how that's really where the sink in the Factom system lies. Similar a little bit to the Ethereum structure in the way that their tokens work. But one important difference is factoids are the tradable token, but entry credits are assigned to a public key. So the public key can't be traded, it can't be moved, it can't be changed. The entry credits are sort of, all you can do with them is make entries into the system. So it separates holding a cryptocurrency wallet and using entries into the system. So that's really helpful for big institutions that don't understand crypto yet, but they want to use the immutable blockchain. So anyway, that's a quick overview. I'll just open it up for questions and ask Brian if he wants to add anything to it. But thanks everybody for your interest.
Thanks, David. You have questions?
Yeah, so not sure if I'm heard. Am I heard?
Did you hear him, David?
Yeah.
Maybe a little louder.
I can hear you.
Okay. Yeah. So basically, maybe if you could say in a nutshell, what is the technology, the technological background that makes this database unerasable, basically. So how just in a nutshell, how is it done?
Sure. Brian, why don't you speak to that, kind of go through how the hashes work?
Sure. So we like to say that it's secured by the Bitcoin blockchain. So at a technical level, we're making a publishing platform that basically does two things at once. So Bitcoin solves two problems, but they're very difficult to solve at the same time. One of them is being censorship resistant, and the other being spam resistant. You can have either one of them very easily, and have both of them easily with centralization. But having it be decentralized is a difficult problem. And so that's what we're trying to achieve. We are the Factom servers are basically creating these data structures, which will then be keys into a distributed hash table. And then the idea is that servers all over the world will present this the data that gets published and store that in various availabilities around the world. So Factom per se is not storing the data outside of the data structures to find the data. If that answers your question.
Well, and I think the aspect of immutability comes in because Bitcoin is immutable, right? Once you've placed a transaction into the Bitcoin blockchain, that block is going to be stored by all of the nodes in the system, and it can't be changed by anybody in the future, right? The transaction ledger is unchangeable. So by placing a hash into that block, and eventually that block is confirmed and other blocks are built on top of it in Bitcoin, now you can follow that hash back to the directory block in Factom and look at all the hashes that were in that made up that hash. And then you can look at a particular entry and say, okay, that particular document is this hash in the directory block, which proves that that document was in exactly that form at exactly that time when it was placed into Bitcoin. So it's extending the time stamping from Bitcoin from a single entry to millions of entries, or as many that you aggregate during that 10-minute period. Does that make sense?
Yeah, exactly. This was the information I was missing. Thanks.
Cool.
Yes.
Anyone else?
And to build on that a little bit, so proof of existence already works. That is a website where you take documents and you can hash them into the blockchain and pay a small fee per document. And it would be pretty trivial to basically take that and take a whole bunch of documents and then basically hash a Merkle tree or hash a hash of all the documents. And it would be very easy to prove a positive. So if we take a step back, Bitcoin solved a really difficult problem, and it's kind of a philosophical problem too. So it's easy to prove a positive, but it's hard to prove a negative. And so Bitcoin solves this in the form of the double spend problem, by making transactions only be valid if they are in the blockchain. So what a miner can do is they can go through the entire history of the blockchain, and if this money has not been spent in the blockchain, then it can be interpreted as not being spent at all. Now, that's proving the negative, and to do that, you need the entire blockchain. And this is pretty fundamental. So what Factom is aiming to do is making more of a generalized way to prove a negative. Stop me if I'm going too technical at this point. But it's if a system can be defined such that your transaction needs to be within this narrow band inside of Factom, then if it's not there, then it may as well not exist, which makes the Factom system able to have a lot of power, so to be able to reject transactions that it doesn't like. Hence the need for the decentralized aspect of it.
So to bring it back to a use case, the reason this is really powerful and being able to prove the negative is very useful is, let's say that you got a huge database of information. How do you know if a document is missing? It's easy to know which documents you have, but how do you know if a document is missing? Well, if all of the documents have been hashed into a chain over time, you can compare those hashes to the documents you've just received. And if you're supposed to have every document in that entire chain, you can see any missing hashes. So let's say you took every mortgage record from Countrywide and you put them all in a chain, and then Countrywide gets sold to Bank of America. And Bank of America can say, hey, we're missing this data and this data and this data. What happened when Bank of America bought Countrywide a few years ago is they had lots of missing data, and they had no way to audit where the missing data was. And so they just started making up data and filling it in and pretending it was real data, and they got in trouble and they had to pay a $17 billion fine for a big scandal, for the mortgage scandal. So that's a real world use case of how powerful proving the negative is. Does that make sense?
Thanks. Any more questions? Anybody? Great. Well, thanks, guys. Thanks, David and Brian.
Cool. All right, guys.
Thank you for having
Good
us.
talking with you.
Great.
Catch you later.
Thanks.
Bye.
Bye.